Good evening, everyone. So, thermal properties of matter ngarang lu shandong amok to question award pakare do hisi hology ka. Aduga hayengi Sunday gi test sida thermal properties of matter khatang to ni test ka. Duna question angam bagi hology nasi ka I screen share to rage. So here we are. Akoi ngarang question sigi si hot kre sigi si hot kre ka. Si hot kre so question number sigi 2012 ta hang basa. Side ho gudane ka. So, Siddhang is kind of the slab of stone of area 0.36 meters square and thickness of this is exposed on the lower surface to steam at this. A block of ice at 0 degrees Celsius rests on the upper surface of the slab. In 1 hour, 4.8 kg of ice is melted, so the thermal conductivity of the slab is an very simple. Mana heat kayam habadi nasai 100 degree Celsius tagi ka hit kaya mana kena to we have to conduct to we have to adu du puto kadini ka question ji am live question ni noi ngam gadranga moidra sir solve torora tawzira
tawje
tawse ba ka tawse kasi tawse lagi ya yung ka taro muna taro sir solve torora ya sige da hai si akoina again moina puto ai thermal conductivity of the slab never thermal conductivity puto ke haragadi delta q by delta t is equal to haraga thermal conductivity k lerani then a lerani then l lerani then kaino habda t1 minus t2 laigadane yare ko now sigi delta q z sisi hit kayam kaino to ino hamatam da a block blah blah 4.8 kg of ice is melted hiberneva adudi delta qz kai tarni hamatam da l is equal to kina kai khangi q by m neba or delta q by m harane it implies delta q is equal to m into l neba so m di kaina 4 haidi si the sir gram the all ko everything moi chana na dum pibirame sumaina bigidam ne question na je ko adudi angang dus lai de na ko so this joules learning sumainam thammo into to kande so this is the heat and atai changadaba de tagai moine loin piram asidi kaidoba
4.8 old
nati oh chumi thank you Anjali 4.8 oigidamni ko sir na 4 dang e graba male I'm sorry 4.8 oigidamni yes so and time di kay no and moine pz kay no sida delta t is equal to 60 second ka 1 hour nina everything is given kay naman putuhay siya ki putuhay ni ki is kay tare ho k is delta q into l again seasonal ling ni ko sina latent heat of fusion at vaporization ni ko is it vaporization no fusion ne kay ice melt to ni na ko fusion ho lf ho lf ka sida pyramid so lf ne ka okay seasonal ling ki wari ni ko adudi si toro audagi kay le ne a lani then t1 minus t minus t1 minus t2 lerni ka then kay lerni delta t lebra delta t lori kay no sisi da panchalo audi kay lerni 4.8 into 3.36 into 10 to the power 5 into L length distance between thickness in a 0.1 meter ka audi 1 by 10 tare ka 0.1 or then area of cross section 0.36 na tra audi 36 harga by 100 ka 0.36 yes the 36 by 100 to mataka hat kray area zo hape then kay difference in 100 ka 0 ga in 100 ta ni si kem kai de time na kay na 60 hai ta si myam len ka thalo ado answer dam ta jara ni ka 100 ka dai di si 36 si kay na ka kani moi point kem tai ko 6 na ka sira 6 36 ka 0.8 0.8 68 48 hai ta then sigisida 6 na kakpa matamda 6 5 30 yes 6 na kagyani ka 3.36 na tra. Is it 3.36? Yes. So 0.5 the 3 tare ko then 6 so 0.56 into 8 hai tare. Au na si the exam da dinoi thoi ne yengo no 8648 tare 8540 au di 488 di yaw tabra to isa 488 hai kai kaida kai kena tore 4.8 kg of ice is melted ka that in heat of fusion. So heat conduct mana tawri pochina ice asuk melt tawri havani atai di kemti yaw pikeno kadai de kari soire 8648 8540 44 oh 448 tayo ba 44 na traman 8540 4480 tayo but 4480 answer de yawdre aduga point ahum na tra 1 o cc 1 2 3 ka na point ahum am chaladi ani de ma di 4480 taba 4480 di ta de ka area le thickness le lower surface 100 le upper surface 0 le surface in 1 hour 4.8 kg of ice is melted havani aduna 1 hour do 60 ni ka 60 zi makada la ni area makada la kani si la kani L na mathakta chakani delta Q zu mathakta chatkani ka adudi 4480 di tayo ka sisi kadayda kari mistore ina kainom di soire ko sige kamaina kaida soire jana second ka kaida kai soire ina o kaino ne sir na ne kaino da soire sir na ka kaida soire have the 60 second at 60 into 60 ne have the 60 minutes tang all le re ina ka hour ni na 1 hour ni na 3600 second oi gado natro gyan taudra ba
Dai, sir.
like aina kaino aina si 60 du kam ju go sai de 60 yaw le mi kain tin berani C 60 is again C 60 delta T natra C wala mi au di 4480 divided by 3600 tare ko 0 ama 0 amka kra au di 6 na ka ga di 6 ai si gizem ta ka tat kena tre lang khanjale au di 66360 ka then 6 okay 6742 then 28 la di 646530 yar factane adudi direct dum yelo ka rois duvudi atopana ka yani 4 na ka yani ka 4144144428 then 9436 and 0234 yaroi so 112 the 19 ko di 1 to mata 90 tare si 2 le 10 11 2 le si point namo si 0 la then do the 1.2 dum la ni 92 ko 18 so 0 le ni 4 le ni point number 0 la ni ko so 93 9981 ya ro at the end of the kai do ba 4 sa la ni 9436 ai tare ko 360 so 1.24 je tabre me 1.24 joule per meter per second per degree celsius tabra
Dai, sir.
ka sumaina taga da ba so gyan bu ta ho bro
Hi, sir.
अंजलि ज्ञान ता होरबो
Dai, sir.
लाइक शैला ज्ञान ता होरबा शैला सिंथोइदी चेत खुंजरानी को ज्ञान ताद्रगदी दुम तादे हेरो को सर नेक्स्ट क्वेश्चन तौरगे का सो a cylindrical metallic rod in thermal contact with two reservoirs of heat at its two ends conducts an amount of heat Q in time T. The metallic rod is melted and the material is formed into a rod of half the radius of the original rod. What is the amount of heat conducted by the new rod when placed in thermal contact with the two reservoirs in time T in haibako? So sisi nui ngamgadra ngamoidra hairiba potsi kaino have the same coefficient of heat conductivity di chap managadui ko thermal conductivity di only khena duji magi dimension do my area ga length da khenara ne ba aduna hana conductor on heat to adu do chap manana conductor kadra toro idra haibe wane ba do khenare ne ta kahni akoina amana length tagi keno toro padu area do na muka compensate toro puji ai ba do sida budi compulsory khena ni ka so si question sida noi si jingam gadra ngamoi dra sa jaina ro ngamoi di sa tawdi ba tawzira
Sir, do tawrasi.
tawrasa
Oh,
okay tawsi okay yengo ka tawrasa so the high can have the a cylindrical metallic rod is okay in thermal contact with two reservoirs of heat at its two ends conducts an equal amount of heat in time t. So q by t is equal to k a by l arga t1 minus t2 sisina first kinebuka. Now we have that the metallic rod is melted and the material is formed into a rod of half the radius haibnebuka. So half the radius hargadi kaino have the r2 is equal to r1 by 2 nebuka. Aduna pi r2 square is equal to pi r1 square 1 by 4 la nebuka. Aduna kaidoni have the ngasaigi kaidoba area da a by 4 la nebuka. K harga a by 4 la ne hata kaino di sisina q dash harga by t. Okay, fine. So what is the amount of heat conducted by a new rod when placed? All right. So what about the length? A into L A1 L1 is equal to A2 L2 tagadamni. So A1 di A1 adum lere L1 di L1 adum lere A2 di kaino have the A1 by 4 lerni adu di L2 si kyano do puthog yare ka. So A1 kakre and L2 di kaino have 4 times of L1. So L2 is equal to 4 times of L1 there. Yareka. Aduna here you have 4 times of L layrani buka. Aduga adum ngasai same T1 minus T2 to dum laserani hata. Gyan tadabra. This is equation 1, this is equation 2 ne buka. Adu erga what is the amount of heat conducted? Q dash is equal to Iraga 1 by 16 times of Q tarni ka. So option number kay tare? Option number B tabre yung na. Check to.
tai sir.
Taiko. So sir na solve to isida gyan tahudra ba?
Tahu
Tai sir.
Tawi ka sisima adagi sisima tare ka CNE se important way. Okay, fine ka. So it's a very simple question. Now let's move on to the next one. The total radiant energy per unit area normal to the direction of incidence received at a distance r from the center of a star of radius r, whose outer surface radiates as a black body at a temperature T Kelvin is given by and have name ka. So CCD yam live question ni tawzira nang dum tawrojira sa jaina ro. Sa tawos tawzira sisa. Sintoy tawzira.
Hafifan yin
Okay. Tawrse ka medyo nungay taw man. Si khwaidai maru orise noi class yauba kangbusu aduga class yauba ngamjadaba only idoba sarna sigi session recorded session upload torpada yengba kangbugi oragasu ko taw ai kenom haigya yam maru orisi kaino ha matamda sarna already no theory ji takrabane ko aduna aina takiba theory do adudumak sida apply tawineba every question da haitare ko anything out of the blue aina takidaba something panjalakpa kem yaudeba aduna noina sir dagi tamdoi kaino ha matamda sigi kaino ji khatang nateba theory do khatang nateba sir na kamaina question ji paraga kamaina wakhan khalli ab ai dum wangang holini dana noi wari sana sana holini dana aduna aigi sometimes I also make mistakes commit thakpani khangde dagi ngasai 1 hour do 60 second kind of go throw me do soi ni dana ko adaina dum soi badi dum yarokani but कहने पोचे अना कमाइन तौर वाखन खली है थ्योरी ताई खतंग ग्यान ताब मालगू एप्लाई तौर कानदी तसेंग नई ग्यान ताई तादे एप्लाई तौर कान खतंग खंगकनेब क्वेश्चन होल कान खतंग को अदुना सरना क्वेश्चन से पार थ्योरी दो कमाइन पालई है इंपोर्टेंट होइजे वाखन दो थॉट प्रोसेस है पैटर्न है अप्रोच तो अदुनेब लर्न तौगदोइसे को एग्जाम द अदुनेब हेल्प तौरकदोइसे नंगना theory dudi any nang chimpapu ge hagadi anywhere dagi like te dam yeng gasu not saying chimpapu shi ai but aina sida aina sir no hot pasi record to ise and then noi disu share to ise sisi keno to bene ko kamaina ina question ji approach to ge the scientific way the ko adu dune tamai now sigi question ji ngi the total radiant energy per unit area normal to the direction of incidence radiant energy received at a distance r from the center of a star of radius r, whose output surface radiates as a black body at a temperature T Kelvin. Okay. CD keno tare natra. Abdi suppose let's say see star name at a distance r natra center of a star of radius star ki radius ina r name ko. Okay, and who's out so at a distance r da she at a distance r da per unit area sida laigadabar energy to sida phangadaba ko total radiant energy per unit area to putho u na haibane ko adu oiba taragadi ko whose outer surface radius as a black body at a temperature T Kelvin. Now kuina Stephen's constant pyramid Stephen's law gi matungina kuina kai khangi ha matamda energy Q by T Q by delta A delta T है का per unit area per unit time do adu kai ga manai delta Q per unit area per unit time do kai ga managi have the black body ni na small e do 1 tare ko hapak to siare ko emissivity 1 tare black body ki so sigma dang yaw ni ko sigma A haraga kai no T to the power 4 neba ko now sigi A neba ko kaino to godese auna sigi A si kayo ini ha matamda incidence received at a distance r from the center of a star of radius r so radius r okay fine so see or gadi ko magi kedo ya matamda sumaina achauba kayane spherical shape amada per unit area da sida puthokpanina AZ obviously it will be 4 pi capital R square lane. Yan ko. Aduga minus small r so dum season ka. Okay, aduga per unit area so C sigma A. Okay, C 4 pi small r square ngai ko ko sida A or ngai ko service for already amas the layer of nina ko. Si sumai lakada. Sigma A do sida le. Aduga second ko time sibudi yare okay fine sigma T to the power 4 layer then R gi problem name ka R si kamain torga kena to sige habda so moina putho hai si delta Q by delta Q radiant energy per unit area delta Q by delta A ne ka adu or ga di smai lan muni ko si ko delta Q by per unit area ko by a neba puthwai sigi delta a nataba into a layer ne ko adu moina time ju p d ento is ko berani tos
मोइजे इनर्जी पर यूनिट एरिया ओरमनिना ngसागी कइनोदो इनर्जी के फॉर्मूलादो असिगी E सिग्मा सिग्मा A T to the power 4 जे पालेदना अदुगा असिगी सर अमा सिदा पुथोइबा एनर्जी जे सिना ngसागी रेडियस R ओइबा असदगी असिगी पुथोअनिदना अइना हाइजे हाइट अदुगा पर यूनिट एरिया निना एरिया अमना येलोइद्रो
नते नना हाइसी सर न ज्ञान ताब खरदी वाटकिबा मालेबो को नाजे हाइदो मोगी
हाइदि
सिदा हाइरो
इंटेंसिटी दी एनर्जी पर यूनिट एरिया निना अदु खंद्रे जो
नते ngaiku ko sir hairke ko si sida moina haisi total radiant energy per unit area haibane ko auna c gi delta a se area si makhal ani sudoine ba gyan tabra habadi sidagi akoina mana thadora ka duisina 4 pi r square gi area dei thadok small r square hai tare ko magi area sina kaino 4 pi r square oidine ba and then aduga sigi total sphere sigi kedoba magi si distance r da leigidriba total surface area sina kaino 4 pi capital r square oine ko aduna sida hai sida hai si kaino total radiant energy per unit area haibane ko aduna ngasai radiant energy se delta q se hai tare ko CCD sumain thamje ko radiant energy si kaino hai matamda ai si muthalage ko duga delta q dang hai shira so delta q si kaino hai matamda small e d roi sigma a harga t to the power 4 ne ko but now what is this a radiant energy per unit area now sigi a si kai weni hai matamda kaino oigadoineba black body dugi surface area ne ko ana magi surface area di kaino 4 pi r square t to the power 4 ne ko now sida moina sida su problem am leiba radiant energy per unit area haiba khatang si yade asengdi moin puthwai si time am wat level delta t ne ko aduna moina hajik puthwai sina kaino habda delta q by delta t lena and then a amazu puthwa hai at a distance r nina sida leidusi 4 pi capital r square adune puthwa ise adu already kai le ne of the sigma 4 pi r square t to the power 4 ka divided by 4 pi capital r square ne ba now moi di sigi delta t season na dreba ko aduna adu yare dum so 4 pi ka crack sigma small r square ka sigma small r square to the power 4 by capital R square. So option number kay tadeba. A tabre yung na.
Sai sir.
Like so sir na solve to igyan ta hudabra tabra. Ngasai Kirchhoff's law the yauriba delta Q by delta T da is equal to E sigma A T to the power 4 je sigi A se. Sigi surface area of the black body never. Can take surface area of the black body never or whatever body hai tare ka I kind of naman dito is just a second yare ka CC surface area of the black body never ka aduga sida yauribasina per unit area energy total radiant energy per unit area aduna sigi area sidi chawina 4 pi r square aduna sigi sida per unit area da yen thora kya total energy man thadore sidi sisi ne ba ko ana per unit area aduna 4 pi r square duna yelaga sumain tarai ne ba gyan tabang ngam dabra
ngamme sir
Sichos tabra sahila adagi sinthoi ngambro lene mak
Namaste.
Amiko, makha tausi didi. Question number 27, assuming the sun to have a spherical outer surface of radius small r, radiating like a black body at temperature T small t degrees Celsius, the power received by a unit surface at a distance capital R from the center of the sun is an I. Yam live question in sing sir hainer tauzira.
ngomni sir. ngomni hojiktuga chap manadoi natro.
Hajikto hotpaduga chap manadoi natra ba.
mawongdo hadi
Ha.
tida.
Surface at a distance r from the center of the sun is. Yes. Option Z kay tane amatan mo T degree Celsius the layeba. So Kirchhoff's law is valid only for absolute scale never temperatures. Do not T to the power 4 animax yaroi T plus 273 or the swing yaroi bako. Kanta rise. Aduga sigma r square sigma lena ka. Aduga magi assuming spherical outer surface of radius r then 4 pi small r square 4 pi dika cranny small r square kai chakra radiating like a black body and the power received by unit surface at a distance r makha na r square lani mathakta small r square yaudre sigi si
small r square
mamang yawisidi udavani ai chen kai tane de option number A tadura C tadura C tadura 4 pi di kakna grani dana ka adun option number C tabriyo tabra
tai sir
tai ka adumai hokadero mid se small r square gase select train. A black body at 2 to 7 degrees Celsius radiates heat at the rate of 7 calorie per centimeter square second at a temperature of 7 to 7 degrees Celsius, which is equal to 1000 Kelvin. Yes. And sisina kana 2 to 7 or the 500 Kelvin. 500 ka 1000 go the 500 difference later ka. 7 minus 2 5 difference. So at a temperature of this, the rate of heat radiated in the same units will be in heaven. So, yam live question ni. Sisi no ngam gadra ngam wait. So, hena ngam wait di san tau den.
ngomni sir
Ngam ni. Atai di say to boss sintoi sayla ngam gadra.
Ngamisha.
Sintoi ngam dira chetakumo. Sintoi tabra. Sayla tabra. Sayla kumak kidre. Sintoi ju kumak tre sayla ju kumak tre. Anyway, sintoi kume ngam okay, fine. Question number 29 the two ends of a rod of length L and a uniform cross-sectional area A are kept at two temperatures this, the rate of heat transfer option number C darn it's so simple. Option number C. Question number 30. A black body is this, it emits energy at a rate which is proportional to have very simple 1000 to the power 4 kaino 7 to 7 ja Kelvin the on the ya deva ko degree Celsius the pan machine ya deva ko Kirchhoff's law je sorry Kirchhoff's law na te kai Stephen Boltzmann's law or Stephen's law hai tare ka aduna cc ye tare. Question number 31. A black body at this emits radiations with maximum intensity at a wavelength this. If the temperature of the body is increased by this, the maximum intensity will be observed at an hour. So, si chu chap manai, si sina kaino have the Wayne's displacement law ni ko. So, si jing noy ngam gadra ngam moidra. So, zaina ro. Tauzira taurozira.
ngomni
Ni. So, ito boss, sahila. Enjoy.
Ngamisha.
Ni buka. Yare. 31. 32 D. Which of the following rods given radius R and length L it's made of the same material and which ends are maintained same will conduct the most heat. So C gi marak si the karam manak hena kwai de heat conduct tawgani si ngam gadra
ngomni sir
ngamni. 33 si the if lambda m denotes the wavelength at which the radiative emission from a black body at a temperature T Kelvin is maximum then si di ngam gadra
Whence displacement law ꯑꯗꯨ ꯄꯥꯝꯃꯦ.
Exactly, whence displacement law ni. So karamana chummise? Option number
D.
Keva, B or D?
D.
D. Very good. Ka D tare. Question number 34. Consider a compound slab consisting of two different materials having equal thickness and thermal conductivity. Is this the equivalent thermal conductivity of the slab? Is I see sir already derived to grey ko. Kay tay K1 plus K2 by 2 natra. So 3K by 2. Yaudabra.
Not ano si parallel kido ano paladi. Not series.
Series ki pande bas series ki di kay tagi ngarang sir na tawda.
2 K1 K K1 K2 plus divided by K1 plus K2.
Twice K1 K2 by K1 plus K2 natra. Twice 2 to the 4 by 3. Yes, 4 by 3 K tabra. Option number D tabra.
Tai sir. Ado asidayje series ni parallel ni kamay khangdoino ay ngasay parallel ni khalaga hotlakan taramdabadagi series pala tai.
Okay, so kanoni ko slab ani thamina wise always by default series to oigadoine ba. Parallel haiji koi kisu pang hit conduct to matam da ama paulo kan ama paul level ko. Ado direct parallel se moina explicitly ko. Ai direct parallel gi diagram ye maga parallel na uttaba targadi koina series adum lawo ba. Yan dai ko. Kay you know am thermal conductivity do ahamba slab se power matung da akon da slab ang power na ado ana series to chat halo ba nakan ani mak swaina chat pa do adudi thawinki question du da thawinki moina ke do ba explicitly mention to da ba targadi always akoina series adum logani ba gyan tai ko aduga moi sida su question sida kai hai consisting of two different men having equal thickness blah 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 the equivalent thermal conductivity sida kai ham de ko series adum logani bi are ko. So unit of Stephen's constant. Stephen's constant ki unit kai hoini power per unit kari area and to the power 4 ID divided by ko. So power by option number kai tarni D tarni. Yare ko?
Answer.
36. Consider two rods of same length and different specific heats connected blah 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 what having this. If rate of loss of heat due to conduction is equal, then CC kai oidine. Question number 36 si tawzira tawrosira no ngamgadra.
Sir, si ma specific hit pyramid kaso sisinaro ko.
Specific hit se raw. Having and different specific hit conductivities have a cost. Specific hits this and this conductivities, this and this, and area of cross section, this and this having both this and this have a cost. Sizinagani sizinaroi sinani kaino sizinarga yengs se servola gese ko. No sizinai kaino todo ma. Question क्या हम वाली ये चैप्टर जी जाओ लगे question book क्या हम वाली है oh लोइदुरे ने का finally लोइदुरे yeah okay all right here I go so yeah sida same length L1 L2 different specific hits and conductivity this and area of cross section this and both having temperature this if the rate of loss of heat due to conduction is equal okay rate of loss of heat to chamane of the delta Q1 is equal to delta Q2 rate have ni ko by delta T da ani du mane have yare ko it's a very simple question. So you have K1 A1 by again A1 L1 to A2 L2 mana A1 L1 higher I'll simply say A then I A by L then delta Q1 again sisina kaino Cn is
A1 we don't know. A1 harmi.
oh moina kaino haramra A1 harami ko and
Same length over.
same length ko okay fine A1 harani aduga same temperature difference habra mani ko T1 minus T2 aina minus is one to ne T1 minus K T2 is equal to K2 harga A2 by L T1 minus T2 of the loin kaktakraga K1 A1 is equal to K2 A2 tabrang sige option number A tabrang tabra
Dai sir.
got yeah so that's it
Dai. Do ne specific capacity je season capacity.
specific hit se sirinabam leitre ko adin different specific hit hai ado ma isidadi conductivity ni na ko heat conductivity da koi kaino tawde specific heat sirinade specific heat the temperature increase tawrokpadaneba ko aduna question. Now, question number 37, for a black body at temperature this, its radiating power is this, and temperature of surrounding is this. If temperature of black body is changed to this, its radiating power will be singam gadra yam live question ni. I don't know ngamo hari tawdini ngam gadra ngam gadra hainaro 37.
Thermal and temperature of surrounding is haji koi asibo koi.
Okay. Adudi sir tage ko na si manuai to male sir. Like temperature of surrounding ga kenoga gi difference the man heat ka heat se conductor ka man thador ka desi ka aduna very good nang question mun na pare observe fazane observe to wai I fazana ke dawa observe to bagi for a black body at temperature this its radiating power is this so magi radiating power hai p hai ka P is equal to sigma A harga aham by sin kaino 7 to 7 the kaido 273 plus to already 1000 to the power 4 tarni bako aham aduga sigi P is kayeba si 60 watt ka mane bako so instead AC yung ganda 60 times the no yung ngau dana bako on a sigma A 1000 to the power 4 is equal to 60. It's radiating mass, and the temperature of surrounding is this. If temperature of black body is changed to this, then its radiating power have a okay, fine. 227. So 727 degrees Celsius is equal to 1000 degrees Celsius, and 227 degrees Celsius is equal to 500 degrees Celsius. Haitare ko. Aduna akoina yare ko sige. Okay, fine. Now, manane radiate tawgudriba heat se CCD kay if temperature black body is changed to this, then its radiating power is 7 ko. Okay, am tanga tawgiye 1227 degrees Celsius is equal to arga 1500 degree Celsius la ane ko. Aduna
Sino I don't know. Kelvin all.
mane
Ke-
kano torba Kelvin dane kano toije change toije.
Yeah. Anh degree Celsius thăm kari. Kelvin thăm nó là tầm right.
Yarni? Yeah, bro. Okay, fine. Now, hꯧꯖꯤꯛ ꯑꯩꯈꯣꯏꯅ ꯁꯤꯒꯤꯁꯤ ꯀꯩ ꯂꯩꯅꯤ ꯍꯥꯏꯕ ꯃꯇꯝꯗꯀꯣ ꯃꯥꯅ its radiating power is 60 watt and temperature of surrounding. Okay, so sigi 60 watt sigidi kay layni ha matamda akoina sumai layani ko my temperature of surrounding si subtract horne hai it have the this minus temperature of surrounding di kaina 500 to the power 4 is equal to 60. See equation 1. Equation 2, the sigma A 1500 to the power 4 minus 500 to the power 4. Is equal to C power J khangdebaka. So let's say P2 hai option number 2. Obviously P2 is equal to 1500 to the power 4 minus 500 to the power 4 divided by divided by this P2 da C na yela C da na C na yela 16 as is it? Yes, P2 by 16 matakta ka. So into 60 lani. Chumra. Chumika. Aduga makadana kay lakani habda 1000 to the power 4 minus 500 to the power 4 ita. Yam nungaitaba number asisa. So okay fine. Hot pada kradi nungairoi ka. So sisi aina square da on tuwa ka. Aduga plus minus tawbada nungaigadra habda si nungairoi. Matic charn 15 to 5 2 to 5 ki square ang already 25 ki 6 to 5 lane ito tower 0 do 2 to 5 kasi 15 ki 2 to 5 lane 2 to 5 ki ang square lane ka sir 2 to 7 degrees Celsius to 1000 Kelvin hydroneutral 277 d 1000 na t 277 d kano ni 500 ni sintoy gyan tadabra sintoy
Sir, ꯁꯤ 1000 degree Celsius ꯍꯥꯏꯁꯦ Kelvin ꯍꯥꯏꯗꯧ ꯅꯠꯇ꯭ꯔꯣ?
kari
1000 Kelvin ꯍꯥꯏꯗꯧ ꯅꯠꯇ꯭ꯔꯣ?
1000 Kelvin haidun natraba hoi mane keno haidun Kelvin haidun sirna degree Celsius da sum thamale me ko
ꯑꯗꯨꯗꯩ
o sisira keno na haiji sentui na haija Celsius to 1000 Kelvin. Oh yes, but 1000 di nateva 277 di same to me
soꯏꯕꯅꯦ ꯑꯩꯅꯅꯦ
500 ka 500 Kelvin ne kaino hajiki do kaino ro Anjali ro oh Anjali ore me chet oi da sentui ora madran khalin anyway yeah so si hotini so si hotpa matamda kamaina noina si tawni habda si yam thi nungai taw number ni ko aduna noina 15 square okay fine 2 to 5 I go 1 2 3 4 minus 5 square again si yung square ang taw do wali ba ka taw lo again mo ni taw bi lo again kadi nungai ro what kada di si now si le ka si square taw ro adu ang square ang wali square ang wali adu di kay tani si a square minus b square or gadi a plus b a minus b taw ni ka auna into 60 am zo wali ba pazai adu ergadi sigi minus ka plus ka taw matamda ko 0 मैम जा a square minus b square ने बा so सी कहीं ना 0 मरी सी 25 और गदी 250 into 1 2 3 4 सी ना plus तो वही ने को दुगा minus तो वही ना 2 है 1 2 1 2 3 4 divided by plus तो वही ना 1 है 2 5 1 2 3 4 अदुगा minus तो और 75 ergo 1 2 3 4 aduga 60 am wali into tawdo ko kay target sidi yengo kay tare So CC 1 2 3 say 1 2 3 4. Okay. 1 2 3 4. 1 2 3 4. 1 2 3 4. ꯆꯠꯈ꯭ꯔꯦ ꯀꯣ ꯑꯗꯨꯗꯤ 125 into 2 ꯗꯤ 250 ꯌꯥꯔꯕ 25 3 75 25 8 200 ꯌꯥꯔꯕ ꯁꯤ 3 ꯅꯤ ꯀꯣ 3 ꯅ 60 ꯀ ꯗꯤ 20 ꯇꯥꯔꯕ ꯑꯗꯨꯗꯤ 20 into 20 ꯗꯤ 2 2 4 400 8 4 32 320 watt tabra
Bye, sir.
tai ko so aduna aduin tarani yare ko so this is equal to 320 watt haita so sumaina tawgadoini ko it's a very simple question na noi kina torsi ko makha yengasi makha ji kai kai no makha ka kai yeng si andi chatre Which of the following is best close to an ideal black body? Black lamp, cavity maintained at constant temperature, platinum black, a lump of charcoal heated to high temperature. See this one already black body explain to the light rays in manung the changraga tholopasungam the vida infinite reflections adum tawraga mapanda tholandabado aduduna masi lights incident energy si absorb ti tawraga reflect ti tawraktabida oina heat up tawraga temperature increase tawraga emission oin tawdo or radiation oin tawdo adu black body ni auna cavity maintain at constant temperature is the best thing kay gino cavity mong do changrani but constant temperature ha ma emit ti tawrakani or radiate ti tawrakani but reflect ti tawroi so this is the best example of a black body gyan tabra or response gyan tabro ma'am kay kum dise like okay so in say this is may in toram dream once again ka all right yeah ka things I'm mumming do may so the wind's displacement law expresses relation between wavelength corresponding to maximum energy and temperature si chumme radiation energy will lale temperature will lale color of light and temperature option number E su chumme D su chumme ba ko but option number A na he na chumme do na A haro 39 ji kai ta A tabra D tabra
A, die, sir.
D su ya di ai ba kai no di wavelength depend to e ba color ji yan dai ko but kari magi wavelength depend to e color hai se visible range sa khatang ni ko atop range di mo apply to ya da ba aduna D ji mo hapti hapoi dam ni ko ani ji chap mane Alright, so question number 40 da kya hai a cylindrical rod having temperature this and this and the rate of flow is this if all the linear dimension are double keeping temperature constant the rate of flow of heat Q2 will be in heaven. Seizing gadra kayong kumak tre 40 sing gadro nga moidro sarna kayong kumak tre
Sarngamni.
recorded session ta min di nokning ani say to boss ngamadro sinthoi saila
Ngamni, sir.
ngamani ko okay just ngasai gi dimension sing double toksalo ka adu dum lan. So question number 41 okay, a black body has maximum wavelength at this, its corresponding wavelength at this job money. So lambda m into 2000 is equal to lambda m dash into 3000 of this is 2003 of the 2 by 3 lambda m tare ko answer tare 2 by 3 lambda m. Option number B tabrang 41 oh asi orange
Die, sir.
41 B ta later. Then question number 42. The radiant energy from the sun incident normally at the surface of Earth is this. What would have been the radiant energy incident normally on the Earth if the sun had a temperature twice of the present value? Adu 2 to the power 4 d kya no 16 ni 16 times 16 into kai higher ni 16 into 20 di kai na the kai 720 ra sorry 16 into 20 got 6 to 12 212 320 okay into 16
320 done.
16 into 20 is 320. So 320 is option number A. Tare 42A.
Taisa.
Great. 43, the black body is at a temperature of 500 Kelvin. It emits energy at a rate which is proportional to so simple 500 to the power 4. Option number B, Tare. Heat is flowing through two cylindrical rods of the same material. The diameters of the rods are in the ratio this length. If the temperature difference between two ends is the same, the ratio of the rate of flow of heat through them will be I. Si ngamgadra? Yeah, like dimension ni panjalo dum holo. Ngamgadra? Pochira?
Ngamani sir.
Ngamani. Saitebosi kuma kidre ni tawise. Audagi sinthoi ngamadra cheta kumo saila ngamadra. Saitebos tabra?
Tai sir.
Question number 44 ngamadra.
Ngami sir.
Last question 45. If the temperature of the sun is double, the rate of energy received on earth will be increased by a factor of. So simple. Kay tarni 16. Kay no 2 to the power 4 is 16. And option number D taramani 45 se ka. To 45 D tare ka 16. Now see Newton's law of cooling ja no syllabus to yaudravani ba ko. Sir no the theory ju tak khidavane. Ado mathangi chapter thermodynamics ja haugadaba numittuda habidi Monday numita sir na hapet keno tauge ko takke yam thina keno ni live poni ko aine sum syllabus te yaude habagi no je taksan da wani aduna hape chok pam phat haraga si question om je phat hoto loire ko so ngasi gi di sidalo shalazi hayeng akoi ke do what test adum tawgani ko normally tawido do aina hayeng adum tawgani thermal properties of matter phajana parla ko all the best for tomorrow's test. Good night everyone. Thank you for the class.
Good night, sir.
Okay. Close torge ko. Thank you everyone. Good night.